Hi, Sophia. Just gonna give it a minute to see if the others show up too. Today's lesson is going to be 10.5. I have not checked live grades this morning, so I will have to do that when we're done with the live stream. So I'm sure it's there, I just didn't look yet. Hi, Cameron. Oh, you sent it on Remind. I didn't notice anything on there. I can look real quick. It looks like I have 3 messages on Remind. Yeah, okay. Yeah, they're on Remind. I just didn't see it. But I will definitely get that uploaded when we're done. Okay, so let's go ahead and get started. The first thing we're going to start with is just a definition, of course. So this is for dot product. Dot product is, this is a promise, it will be on your final. Okay? So it says if we have a vector a1i plus b1j and a second vector w a2i plus b2j, and of course, oh, my eye is going backwards. See, this is not good for dyslexic people. Maybe I should just do the eye like that. I don't know. I like giving it a tail though, but this math is not for dyslexic people. All right, so we have 2 different vectors, then the dot product. Which the notation is literally what it says. It's a dot in between the 2 vectors. Is equal to a1, a2 plus b1, b2. And this is a promise. This is definitely on the final. So make sure you know the dot product. All right, we're going to break down number 12. So this is what you're going to do for 7 to 16. We're kind of going to do part A and then come back and do another definition and then do part B. So we're going to do actually number 12, and this is what you would do for 7 to 16. So part A says to find the dot product, and they give us vector v is I plus the square root of 3j, and vector w is I minus j. Okay, so here would be your a1. So your a1 is 1. Your b1 would be the square root of 3. Then on your w, your a2 would be 1. And negative 1 would be your b2. So V times W, that's the dot product, is going to be 1 times 1. Well, I guess I could put that in parentheses. Plus the square root of 3 times negative 1. Okay, so 1 times 1 is 1. And square root of 3 times negative 1 is negative square root 3. And that's your answer. And that's how easy it is. So that's a promise. You will have a problem just like that on the final. Okay, so the next one is going to be the angle between the vectors. So this is just another definition. All right, so again, we're going to have two vectors. So if U and V are vectors, then we have the angle theta, and theta is between 0 and pi. And that is determined by formula is cos of theta is equal to U times V divided by the magnitude of U and then the magnitude of V. Okay, so number 12, part B. So this one up here was part A. So it has 3 parts, I think. So part B says find the angle between V and W. So you're going to start with this formula right here. So the cos of theta, and we're using this exact formula up here. Like these are the V and the W. So this is going to be the vector of V times the W. So this is the dot product, which we found that above. So we can just plug that in. And then this is the magnitude of V and the magnitude of W. So this up here, that's the dot product right there. So we might want to make a little note that this is the dot product. Well, we found the dot product in part A, so all I have to do is just plug that answer in down here. So this is 1 minus the square root of 3. All right, if you remember magnitude, it was the square root of A1 squared plus B1 squared. So we're going to have the square root. Okay, so we look up here. So our A1 is 1. So this is 1 squared. B1 is the square root of 3. So that's going to be the square root of 3 squared. And then we'll have to do the w. So your w is going to be the square root of 1 squared. And then your b2 is -1. So that would be -1 squared. Okay, we're going to leave the top alone for now. Okay, so this square and that square root, that will cancel. So this is just 3. 1 squared is 1, so this is the square root of 4. Over here we have 1 plus 1, so that's going to be the square root of 2. Okay, so when we simplify this, I have 1 minus the square root of 3 over, well, the square root of 4 is 2, so this is 2 square root 2. All right, and then we're going to need to rationalize the denominator. Well, I think you could just type this in probably as it is. I'm going to go ahead and rationalize the denominator just to show you. But basically, to get theta, you're going to want to do a cos inverse. So you would want to get this as a decimal. So technically, you could just type that in and get that as a decimal right now. But just to show you how to rationalize the denominator, we would times top and bottom by the square root of 2. And then I would go ahead and distribute this on the top. So 1 times the square root of 2 is the square root of 2. And the square root of 3 times 2, so 3 times 2 is 6. And then on the bottom you would have this 2, and the square root of 2 times 2 would be the square root of 4, which is 2, and 2 times 2 would be 4. All right, and then you're going to want to type this in. You want to get this as a decimal. Like I said, you probably could have just typed that part in and got a decimal for there. Okay, so square root of 2 minus the square root of 6. Okay, so that's that, and then we need to divide it by 4. So I get -0.2588. We'll just do a couple decimals. The more decimals you give, the closer to the real accuracy you are. Okay, so theta, since this says cos of theta, I'm going to need to do a cos inverse of that decimal right there. And I believe the calculator needs to be in degrees. Second cos inverse, -0.2588. And that gives us, if I round that, that's about 105 degrees. So that would be your answer for B. I think this was on the final too. Maybe one problem. I don't think there was a lot, but I do think that was probably on the final. Okay, this next definitions, this is definitely a promise it's on the final. It's the difference between parallel and perpendicular. He definitely focuses very hardly on this. Okay, so for parallel, you have to have 2 vectors. And, all right, so let's start this out. So for parallel, we have 2 vectors. V and W are parallel if there is a non-zero scalar and remember, scalar is just any number that you can times by. we're going to call that alpha. So that vector v is equal to alpha times vector w. And in this case, the angle in between them is 0 or pi. Okay, so this answer up here would have to be a 0 or pi. So pretty quickly you can see that this one's not going to be parallel. Alright, so perpendicular, he will never use the word perpendicular. It's orthogonal. He will use orthogonal every single time on the final. So orthogonal means perpendicular. And he will use the word orthogonal. He will never use perpendicular. Alright, so we have two vectors are orthogonal if the dot product is equal to 0. So two vectors v and w are orthogonal if and only if v, and that's the dot product w equals 0. So this means dot product. Okay, so number 12, question C says to state if the two vectors are parallel, orthogonal, or neither. So 12, part C. All right, basically you've already done the hard work in part B. So if you have to find the angle, I like to check first to see if it's orthogonal. So how I check if it's orthogonal is I just do the numerator. So anytime I'm finding the theta, I do the numerator first. If it's 0, I can stop because I know then it's orthogonal. So if I look at the numerator, I have 1 minus the square root of 3. That is not 0. So this is not perpendicular. It's not orthogonal. And then I check the parallel by actually finishing out the problem. And I did not get 0 on here. So that is neither. So this one's neither. Okay. All right, now I did want to give you some examples where it was parallel or it was orthogonal, just so you would know what those actually look like instead of giving you a neither one. So I'm going to have to write on the back of this now. Okay, so next example. This one just isn't in the book. So this is 3i minus j is vector v, and w is 6i minus 2j. Move it so we can actually see it. And we're just determining if it's parallel, orthogonal, or neither. And this is definitely on the final. It'll give you two equations and he'll ask this exact same question. So I always kind of jump in to checking parallel, and I always do the top first and then I do the bottom. All right, so for parallel, we have the cos of theta is equal to v dot product w, and I would work that out first. Then we have the magnitude of v, and then the magnitude of w. Okay, so the dot product on the top, we're going to do 3 times 6 plus, this is -1 times -2. Okay, I'm not even going to worry about the bottom. I'll write the bottom in after I do the top. All right, so 3 times 6 is 18. -1 times -2 is +2. So 18 plus 2 is 20. So right then and there, I know that this is not orthogonal because the top was not equal to 0. So I will proceed in finishing this to see if it's parallel. All right, so we're going to do the magnitude on the bottom. So that's going to be 3 squared plus -1 squared. And then your second one over here is going to be 6 squared plus -2 squared. Okay. All right, so 3 times 3 is 9 plus a 1, so that's going to be a square root of 10. 6 times 6 is 36 plus a 4, so that's going to be 40. Okay, 10 times 40 on the bottom, that's going to be a 400. All right, and then at this point, I would just type that in the calculator, get you a decimal. So 20 divided by the square root of 400, that gives me 1. So then theta is going to be the cos inverse of 1. And you want to make sure your calculator is in degrees. And that gives me 0. So since this came out to be 0, this is parallel. Okay, and then we're going to do another example. The exact same thing, just determining if it's orthogonal or parallel. So our vector v is 2i minus j, and w is going to be 3i plus 6j. If you write this out every single time, it will help you remember it. So v plus w divided by the magnitude of v, the magnitude of w. Okay, so we got the dot product on the top. So that's 2 times 3 plus -1 times 6. I'm not going to worry about the bottom till I know the answer for the top. Okay, so 2 times 3 is 6, And negative 1 times 6 is negative 6, so 6 minus 6 is 0. So since the top was 0, we can stop, and you know that it's orthogonal. Meaning it's perpendicular. So I always do the top and then I do the bottom. It's way less work if you do it that way. Okay, the next one we're going to do is number 18. I'm assuming you have to do number 17. Okay, so number 18 says find B so that your vector V and your vector W are orthogonal. Of course, you can just read this in the book. You don't technically have to write it down. Okay, so there's your vector V. And your W is I plus some unknown B, which we'll have to find that. It's not is, it's R. Orthogonal. I'm trying to think. I feel like this one was on the final two. Possible. I'll have to look again. But this might be a possible final. Not 100% sure, but I feel like something similar to this was on there. Except for I feel like they used the letter A instead of B on the final. I think the same concept was on there. Okay, so for things to be orthogonal, the dot product has to be equal to 0. So we have V times W has to equal 0. And you're going to just plug in what they gave you, just as much as you know. So I have 1 times 1 plus, this one's a 1, and that's a B. You're just going to plug them in just like that. 1 times B equals 0. And then you're just going to simplify and figure out what B is. Well, 1 times 1 is 1. 1 times B is B. Okay, you move the 1 to the other side by minusing. So B is equal to negative 1. Okay? Alright, and then we have one more concept. This one's a little bit more harder sometimes for us to explain it. But we're going to use this picture from the book because they can draw a better picture than I can. And I'll try to explain this using this example and then another example that we have to actually use it for in X-ray in real life. Okay, so you have this box sitting on a ramp. Okay, on this you have two forces on this box. So one of the forces is pushing the box forward. Okay, and then your other force is going to push the box. That's probably gravity. Well, gravity might be using both, but pushing the box actually against the ramp. Okay, so sometimes you'll need to figure out how much force is given in a different direction. So this force down here, since gravity kind of forces on both of them, the pink line right there would be gravity pushing that box down. So you have a force that's pushing it down the ramp this way and one going this way. So you need to find the one kind of in the middle. Okay? Alright, so let's look at this as a little bit simpler diagram. So I'm going to kind of redraw this. Okay, so we're going to start out right here at position P. This is going to be a 90-degree block. And we have this vector W right here. All right. And then this is how I like to think of it. Here's another vector. This is V. When we're taking x-rays and you have a broken arm, all right, the best way to view that broken arm, so this would kind of be like your arm, is to get one that is parallel to the break and one that's perpendicular. So anytime we x-ray anything, we always have to get two views. All right, and that's kind of called a vector projection. So that's the best way sometimes of doing things, is to decompose the vector into two separate vectors where one's parallel and one's perpendicular, so that you get the best view of what's going on with the anatomy. Okay, so one of the vector views is this way. So this is view 1 right there, which is going to be parallel to that W right there. And then another one, which compared to W would be perpendicular. So that would look this way. So this would be your V2. So vector 1 is called the vector projection of V onto W. All right, and then there's an equation to find these things, okay? I'm not 100% sure these were on the final. Honestly, I'm going to look at the final again. I know that there's at least one problem in the book on this, so I wanted to at least go over one problem so that you had an idea of what was going on with the homework. But needing to know it for the final, I'll have to look, but I'm not 100% convinced this is on the final. All right, so here's our definition. If V and W are two non-zero vectors, the vector projection of V onto W, and then I give you a formula. Okay, so here's the formula. V1 is equal to the dot product on the top divided by the magnitude squared times W. Okay, and then of course we have to do the decomposition part. I'm just giving you a second to write. So the decomposition of V, of course, let me move it so we can see it, into V1 and V2. Where V1 is the one parallel, V2 is orthogonal. So V1 is the dot product of V and W divided by the magnitude squared times W. And then the second one, V2, is V minus V1. Number 19 to 24. Let's follow. Our example is V is equal to I plus 3J, and W is equal to I. Directions are pretty much the same directions that they gave you in the book, because it's the exact same directions that listed for 9 times the W, that's the dot product, over the magnitude of W squared times 1. So we're going to do the dot product here on the top. So I have 1 times 1 plus 3 times n. Now this W off here to the side, we just leave that as W because that's magnitude squared. Okay, so W is going to be 1 squared plus 1 squared, so that's the square root of 1 squared plus 1 squared, and then that whole thing squared. Okay, so what happens here is this cancels out with that. So basically we're looking at 1 plus 1, which is just 2. So our bottom is going to be 2. On the top we have 1 plus 3, so that's going to be a 4. And then we have that vector W. We'll get to vector W here in a second. I feel like it's easier to plug it in at the end than it is to plug it in at the beginning. So when you hit this, you plug in the given from the beginning. And I just like to wait to do that at the end because I feel like it's easier. Okay, so this is 2 times I plus J. And then you can go. And then we just have to do the last one, which is vector V2. So vector V2 is V minus V1. Okay, so V is I plus 3J minus, and V1 you just found, this is V1. So you're going to plug that in down here. So that's 2I plus 2J. All right, now you want to distribute your negative over here. So change that, make these both negatives. And then you just want to combine your like terms. So 1 plus negative 2, that would be a negative 1I. So that's just negative I. And 3 minus 2 is just a J. So that's your answer for V2. All right, now you need to go to your homework paper, which I don't believe I did this beforehand. I'll write it down on this paper too. But if you go to your assignments on 10-5, number 31, scratch that out. You do not need to do number 31. It is not on the final. I did a similar problem and it took me like literally 2 pages front and back of notebook paper. So skip number 31 on the homework. So cross that out. Don't do number 31. That problem is ridiculous and it's not on the final. All right, do we have any questions? Because that was it for the notes for this. And I need you guys this week to get done pretty much with everything. I need you to get Lab 10 done, all of the homework quizzes done, work on your homework, get that all finished. Everything is, the last day I can take stuff is the 30th because I need to get everything graded. We will talk about the surveys on Monday and we'll do the study guide on Monday. And then I want you to take, there's 2 parts of the final, Friday, May 4th. Of course, if you want to do it earlier, that's fine, but I do need you to tell me when you're going to take that final. Okay? So is there any questions? Well, I'm not seeing any questions showing up. So just hit me up on the Remind app or on Live. If you want to drop the class, I need to know by Friday because Friday's the last day to drop. You do not get your money back. At this point, we're so close to the end. I feel like you should probably just try to finish it. But if you, while I'm doing live,